Hello, welcome to my channel. So today we are going to look at the Leetcode 673, number of longest increase in subsequence. The question is pretty short. Given an integer array norms, return the number of longest increase in subsequences. So the sequence has to be strictly increasing. So let's look at the examples. 1, 3, 5, 4, 7. So the output is 2 because there are two longest increase in subsequence. Each of them has a length of 4. And the second example, 2, 2, 2, 2, 2, the output is 5 because there are actually 5 longest increase in subsequence. Each of them has a length of only 1. And the constraint is the number of the number of elements in norms is less than or equal to 2000. So to answer this question, we actually can apply what we have done for the longest increase in subsequence, which is another question. And for that one, we actually need to define a DP array, which is the length. It's actually the length of the longest increasing subsequence ending at index I. This is the definition of DP function. And so we can actually firstly look at how did we solve that question. So if we have an array and we can, if we have an index j, which then we have an index I. So and also the norms, if norms j is smaller than norms I, then we actually can concatenate the ith element to the the increasing subsequence that ending at j. So we actually can actually update the DPI this way. And so for this question, the only difference is we actually need to get the number of longest increase in subsequence. So we not only need to get the length of the longest increase in subsequence, but we also need to get how many subsequences are with that length. So to solve this, we can actually define another DP function. We can call it a count_i. Then we can actually define it as the count of the longest LIS ending at index I. So so actually we can update the count_i with there is two possibilities. There are actually three possibilities. So the first possibility is if we have a new length which is higher than what we already have, so firstly we can reuse this condition. So we actually can have a new length called dpj plus 1. So if we have this length which is higher than dpi, then actually we um we can update the count I with count j. Actually, the count I will be equal to count j. But if because the number of LIS ending at I with the length of dpi will be equal to the number of LIS ending at index j. Another possibility is if the length is identical to dpi, then which means we already have the longest length at the dpi, but we actually need to add the count j to count I and form the new count I. So update the count I with the addition of count j. Because we found the count I before this step is we can have other index before count j which is the same which will form the same length with I. So yeah, actually this is basically what the algorithm will be like. And we can start coding. So firstly, let's get the length of nums, and then we need to loop, or we need to define the dp, and then we can define also the count. Let's do the also we actually need to do some initializations. So we actually need to initialize all the index all the element of dp as 1, because the longest increase in subsequence ending at each index will be minimum 1, because the element itself is also a longest increase in subsequence. So similarly, the count, we actually need to define the count also as 1. So now we can start the looping, and so now if the nums, yeah, we actually j need to be smaller than I. if the norms j is smaller than norms I, then we can let's copy paste what we have in the bottom. Yeah, so if the length of dp which is equal to dpj plus 1 is larger than dpi, then we need to also update dpi equal to length, and we need to initialize the count I to become j. Similarly, if the length is equal to dpi, then we don't need to initialize because the dpi is already length, but we need to add the count j to the count I. So after this double loop is done, then we actually have a we actually have the count recording the count of the LIS ending at index I. So but we actually need to another thing is we need to have a max length, which we will record the longest increase in subsequence. So we can update the max length in this loop with each DPI. So then we will have the length, the maximum length. Now the last step is we need to iterate through all the DPI, so that if the DPI is equivalent to if the DPI is equivalent to the max length, we can actually add the count to the answer. So actually, this I we can start with the max length minus 1, because the smaller I they will not have. It's impossible for them to have a LIS with the length and max length. So now, so if the DPI is equivalent to the max length, we add the count I to the answers. So in the end, we just return this answer. And let's have a look if there's everything is here. Okay. So let me try 2 examples. Oh, something is wrong. So it get as one each answer. Count. Yeah, actually, we can try debugging the code. See what's the problem. One thing we can do is we can print out all the DPI. Similarly, we can print out the counter. DPI, why it's 1, 2, 3, 4, 5. Oh yeah, actually we forgot this condition. So only when the condition is there, we can have this part. If the condition is not there, we actually cannot. We can actually not. We actually cannot update the DP and count. So okay, yeah. Actually, when I go to the code part, I forgot to add this. So now it should. Yeah. So now it's correct. And so let me submit it. Okay. So in the past, and the time complexity is n square because there is a double loop. So because the n is smaller than or equal to 2000, so the n square time complexity is still okay, and it shouldn't be a problem. And okay, so thank you for watching, and if you like the video, please subscribe or click like button. Thank you.